Hello, my name is Sahil Rajesh Polankar and I am MBA in Finance, and today my classification capstone project topic is on credit card default prediction. The points of discussion for this presentation would be problem statements, understanding the data set, data pre-processing, exploratory data analysis, feature engineering, machine learning model, feature importance, champion model performance, challenges faced, and conclusions. The problem statement of my presentation is this project is aimed at predicting the case of customers' default payment in Taiwan. From the perspective of risk management, the result of predictive accuracy of the estimated probability of default will be more valuable than binary result classification, credible or not credible clients. So let's understand the data set. The CSV file that we have provided is the default credit card.xls, where default payment is the response variable, which has 1 and 0 as its values, where 1 corresponds to yes and no corresponds to 0. Data field that there are 23 variables used in this data set. They are as follows. X1 denotes the amount of given credit. It includes both individual customer credit and his or her family supplementary credit. X2 denotes gender. 1 corresponds to male, 2 corresponds to female. X3 corresponds to education, where 1 is graduate school, 2 is university, 3 is high school, and 4 is others. X4 denotes marital status, where 1 corresponds to married, 2 corresponds to single, 3 corresponds to others. X5 denotes age which is in years. The columns X3 to X11 denotes history of past payment. Past payment of 6 months, that is September, April, May, and so on. X12 to X17 denotes the amount of bill statement of the 6 months. X18 to X23 shows the amount of previous payments of the months of the 6 months, such as September, April, May, etc. So data pre-processing. Data linear processing requires cleaning of data and preparing it for further analysis. For data cleaning process involved the following parts. Replacing pay 0 to pay 1, from 0 to 1 to maintain the sequence, as 0 does not signify any month number, and the rest columns all have the numbers starting from 1. Then the next step was changing the column names from integer to month names for better readability down the line. The creating age buckets column for further analysis was lot of invalid data such as education, marriage, etc. Education had 5, 6, and 0 values which had no meaning. Hence, we imputed it to 0, which corresponds to others. Marriage had one another such value such as 0. We imputed it to 0, which denoted others in this column. We replace the negative values present in promo open, competition open with 0 value, as those values does not have any meaning. Next step was null value treatment. Since it is a payment history data, we were lucky there were no null values in our data set. Next step was handling the outliers. Our data set had 30,000 rows and 26 columns. Before outlier treatment, we used the box plot method to detect the outliers. Since 90% of the pay data lies between -2 and -1, we tried to eliminate the rest of the observations. Removing outliers using z-score method on limit balance column. We treated the age column by dropping values more than 61, as 90% of data was less than 62. We treated education column by dropping the values more than 4, as 90% of data, as the data was less than 5. After all the outlier treatment, the number of rows that were left with us were this many, 20,928 rows. Number of columns that were left were 26. Further outlier treatment was done at data stages by creating two columns, payment value and dues, that treated both outliers as well as multicollinearity heavily. These are the box plots before outlier treatment. As we can see, there are multiple outliers over here, also over here. There are only few outliers which are denoted by 4 shown here. As you can see, after the outlier treatment, most of the outliers were eliminated. Let us understand the dataset. The dataset for customers default payment in Taiwan, basically that was a dataset, and the shape of the data is 31 rows and 25 columns. 6 months bill payment and bill data was available. There was no null data. 9 categorical variables were present. ID column could have been dropped. As we can see over here, we have obtained this information from df.info info method of pandas data frame. Next EDA that we performed was on ratio of defaulter to non-defaulter. In a dataset, the ratio of defaulter to non-defaulter is 78 to 22, but 22% are defaulters while the rest pay on time. The gender distribution in a dataset was 39% males and 61% females. The defaulter ratio with respect to gender is 43% of males are defaulters, while 57% of females are defaulters. The defaulter ratio according to marital status are as follows. 50% of married people are defaulters, while 49% of unmarried people are defaulters, while single percent, only 1% are defaulter. The above EDA suggests that married people are more likely to fail to pay on time, while single people often pay on time. This is the EDA that we have performed on past payment, history of past payment, who paid early or who are not likely to default their payment. Next EDA that we have performed is on the age column. The trend of age column and limit balance column. The trend of limit balance mixed from age 31 to 39. It's increasing. After that, it has declined a bit from 62. It is again increasing, and the limit has increased drastically. As you can see at 79, highest limit balance was given at age of 79. Next, we performed feature engineering. We created payment value and due columns from X12 to X17 columns, and X18 and X23 columns. As we can see, there was large number of multi-collinearity, high correlation between the columns, and we have tried to reduce the correlation by creating payment value and due column, as you can see from the heat maps. Next step was handling the class imbalance. We use SMOT among the available methods for handling heavily imbalanced data. As you can see, before handling class imbalance, the data was heavily leaned towards not defaulters, and after handling class imbalance, as we can see, the data has been balanced. Next step was scaling the numerical features. We use standard scalar to scale numerical variables by removing the mean and scaling to unit variance. Next step was dummification. We use get dummies to convert categorical variables education marriage into dummy variables of 1 and 0. Next step was machine learning step. After performing all these steps, our data set is ready for machine learning modeling. Now we will train our model over a set of data, providing it an algorithm that we can reason over and learn from those data, and then make prediction on those data which hasn't been seen. After ML model analysis, these are the results. The XGBoost classifier and random forest classifier have performed better than any other classification model, 83% and 84% precision respectively, while having accuracy of 83.6 and 84% respectively. We performed hyperparameter tuning after machine learning step, and again we can see that XGBoost classifier and random forest classifier has performed better than any other classification model with similar precision and accuracy values. These are the best parameters that we have derived from the grid search. Next step was plotting the classification matrix. As you can see, the decision tree has increased its matrix along with random forest. Next step was finding the feature importance of the tuned models. The feature importance of tuned models and untuned models is in front of you. As you can see, this column, dues column, has highest number of feature importance in most of our models. Next step was performing cross validation on a model. We performed cross validation on random forest classifier, and these are the results. The average time for fitting the estimator on train set is 1.6. The average time for scoring the estimator on test set is 0.117. The average accuracy for estimator is 0.83324. The challenges faced while performing this project were handling understanding varied banking data, 30,000 number of records and 24 number of fields, columns with improper data types, wrong values, combining and creating and removing columns, records containing more than 50% of null values and replacing it with substitutes, removing and replacing outliers from dependent and independent variables, reducing the skewness from variables, feature selection for ML model, converting columns with categorical variables to integer type and scaling numerical variables for regression models, performing and choosing the right kind of model. Hyperparameter tuning consumed a lot of time and computational resources. The conclusions that we have derived are as follows. The number of people who will default their payment is much less than the number of people who will pay on time. The number of females are much more than males in a dataset, and we can also say that females tend to pay their default on time compared to their male counterparts. Married people are more likely to pay their default payments compared to single and others. We can also say that singles do not pay their default marginally compared to the married counterparts. From pair plot 1, bill amount for each month is highly correlated with each other. Hence, we try to featuring engineering bill amount to reduce column to reduce multicollinearity. From pair plot 2, we can see that pay amount tends to clutter at one place. Hence, we tried to feature engineer pay amount columns to one payment column to declutter our data. So the history of past payment analysis is clear that most people who pay duly are not likely to default on their payment. Hence, we can say that from age 21 to 39, limit balance is increasing. However, from 39 to 60 it is said to decline. Then from 60 to 79, it has increased drastically. From a data set, we use multiple algorithms such as logistic regression, support vector classifier, decision tree, XGBoost, random forest. Random forest is the best performing algorithm as shown below. It had a best value accuracy of 84%, best precision score of 84%, best value recall score of 83%, best F1 score of 84%, and best ROC score of 84%. Random forest classifier give highest impounded dues, then payment value, and then to bit balance column accordingly. The performance of our best model random forest classifier with parameters min sample split equal to 4 and parameter random set equal to 42 with grid search parameters min sample leaf equal to 1 and min sample leaf equal to 4 according to class method of SQL. Thus, average time for fitting the estimator on the train set is 1.6, average time for scoring the estimator test set is 1.1, the average accuracy for estimator is 0.8. Thank you.